All right. Well, we're going to spend a lot of the term talking about how things move. So we need to be able to describe the way that they move, and that's what that's what we're going to start with on this first little video about displacement, velocity, and acceleration. All right. So kinematics, that's our first unit. It's really our first two units. We're going to do 1D kinematics, then 2D kinematics. Um, is the study of motion. It's probably not a word you're very familiar with, but that's all it means. It means that we're talking about describing motion without paying attention to what is causing that motion, which we get to when we get to force and dynamics. So to describe motion, we need a way to place it in space. And that's what a coordinate system is, okay? So we need a coordinate system that says, here's the middle, that's our origin. And then we need to have one or more axes headed in positive and negative directions to be able to say, okay, it's moving in the direction of this particular axis so many, feet or yards or meters or centimeters, whatever we're measuring. And that's what those axes do. So the origin places our coordinate system, and then our axes give it directions. So there's a pretty common little coordinate system set up with our positive and negative y direction as our positive and negative x direction. So that's a 2D coordinate system. It allows us to define a position. That is, once we have this map and we placed that in our space, we can say, okay, this spot here is at x equals 3, right? This spot here is at y equals 4, and this spot here is at y equals -1. So those axes allow us to define particular places in this space. We can do that in a 1D way with a coordinate system like this, right? All we have here is a 0 and then an x. And we can say, okay, here at x0 or at x0, that's where I'm starting. I walk back to the restroom here, and I get to xf, where it smells more. In this map, I always end up sitting in the back of the airplane because I buy my tickets late and it's always smelly. So here's a 2D map. And here you can see, okay, we take this abstract idea of a coordinate system and we can place it onto a physical space, right? So that if I say I want to end up here in this city, I'm going to move 10.3 blocks this or 9 blocks this way, right? And 4 blocks or 5 blocks this way. So my x value is about 9. My y value is about 5. And then we'll get to this later. We can actually measure that distance too into those spaces between our different points. So that's position. That's our starting point. Here we are in a particular place. Now displacement is a change in position. Okay, so when I walk back from my first class cushy seat here back to the smelly bathroom back here, I've changed my position, and that is a vector. What does that mean? Well, it means that I moved in a particular direction. I didn't just move 20 meters, I moved 20 meters in the negative x direction. Okay, if I go then back to my cushy seat and have myself a gin and tonic, I'm going to move 20 meters in the positive x direction. So a vector tells us not only how far, but in what direction. A scalar is just a number, right? So I moved 20 meters. That's a scalar, but it doesn't tell me what direction it is. If I say I moved 20 meters in the negative x direction, that's a vector, which we represent by an arrow. So you can just think of a vector as an arrow. And in fact, when we represent it, oftentimes we just put a little tiny arrow above our x. Here are some vectors in a 2D space, and that can get a little trickier, and that's when we'll do 2D kinematics. So you've got something to look forward to here. And we'll start adding those, right? We can add these vectors. If I add this vector to that one, right? Let's say this is -5, 5 in the negative x direction. This is another 5 in the negative x direction. We can pretty easily figure out, oh, from here to here, then I've gone -10 in the x direction. It's a little more complicated when we start adding 2D stuff. Oh, here's an image that I forgot was on here. But again, that displacement, change in position. I start here, I end there, and my displacement has an scalar value in a particular direction. In this case, the positive direction. So we got position, we've got displacement. Now we want to talk about how long it takes us to make that change, that displacement. And the rate of change is a velocity. And so velocity is displacement over a change in time. Our units are, if we remember from last time, length t to the -1, so length over time, and standard metric is meters per second. So velocity is a change over time. Like displacement, velocity is a vector. It has a particular direction. When we say speed, on the other hand, when we're in a physics class, we're talking about a scalar. Okay, so I might be going 60 miles per hour towards Chicago, right? So I'm going 60 miles per hour in the west or east, which direction is Chicago? In the east direction, and that's a vector. But if I just said my speed is 60 miles per hour, I could be heading to Muscatine, I could be heading to Iowa City, I could be going down to St. Louis, and it would no longer be a vector. It would just be in the scalar speed. A little mathematical definition here of velocity. That's our average velocity. When we put that little bar over it, that means average. Is our total displacement divided by our total time. So in that case, if we want our average velocity, all we have to do is find out where I started, where I finished, subtract those, and see how long it took me to get there, right? So if I traveled 120 miles in 2 hours, then I've got 120 miles divided by 2 hours, and that's going to be 60 miles per hour. As we move towards a sort of calculus way of seeing the world, our instantaneous velocity is that same definition here, right? How far did we move in what amount of time? But as our delta t, as the time gets smaller and smaller. So how far did I move in that millisecond? It's not going to be very far, but I'm dividing by a millisecond. And so I'll still get an instantaneous velocity that is correct. So let's look at what this looks like when we try to plot displacement, velocity, and speed. So here we are, we're going to imagine I'm jogging from my house to the store and back. Not a very exciting jog here. I don't know why you're jogging to the store, but that's where we're jogging. So we want to plot that. We want to be able to show what happens over time. So we put our time down here, and we put our position here. And you can say, okay, I start at x equals 0, right? Here's my x equals 0. I'm going to move over the course of time to x equals 3. This is my x equals 3 in the positive direction, right? And then I'm going to move back, okay? So I'm going to get back to x equals 0. So we need to get back to here, that x equals 0, to be back home. And then we plot the length of time it takes us to get there. Now we can also plot our speed here, right? So let's say, here in a quarter of an hour, I've traveled 3 kilometers. So 3 kilometers divided by 0.25 hours, that's going to get me 12 kilometers per hour, right? So my velocity here, my instantaneous velocity is 12 kilometers per hour this whole time. Then immediately here, I turn around. So we get a little disjuncture here. And I'm headed back home, but I'm headed back home at the same speed, right? My speed is still 12 kilometers per hour, but my velocity is in the negative direction, right? If here is x equals 0, here is x equals 3. When I go from here to there, my displacement is negative 3 kilometers. And so my velocity then is negative 12 kilometers. Now, if I wanted to plot my speed would be the same the whole time, right? So I've got 12 kilometers per hour the whole time because speed is a scalar and not a vector. Finally, we can talk about the change in our velocity over time. And the rate of change is velocity is called acceleration. Here are units. And they look kind of funny, right? What is a meter over second squared? Well, it's a lot easier if we write it this way. It's meters per second divided by seconds, right? So our acceleration is our change in velocity, which is going to be units meters per second divided by time. So if I start off and I'm going 10 miles per hour, and then a minute later, I'm going 20 miles per hour. My change in velocity is 10 meters per second per minute, right? If I'd made that change in 1 minute. And so my acceleration would be 10 meters per second per minute, which is a weird units. So we wouldn't do that. But the basic idea here is this is the sensible way of thinking of the units. This is conventional. This is what you'll see most of the time. You'll see that these definitions are very similar here. So average acceleration, we just find our acceleration at our starting point and our end point and divide by our time, just the same way we did with velocity.